We always kind of think of our solar system as like, this calm and peaceful place, but actually it's been on this like wild ride, literally surfing on this like gigantic wave of gas and dust. And it's called the Radcliffe Wave. So buckle up because in this deep dive, we're exploring some really groundbreaking research about this cosmic wave and how it may have messed with our solar system, even impacting Earth millions of years ago.
Yeah, it's remarkable. This isn't just some like abstract concept. This wave, it's actually left its fingerprint on our corner of the galaxy.
So we're talking like actual tangible evidence.
Yeah, exactly.
That's incredible. The research suggests that our solar system cruised through this wave maybe about like 13, 14 million years ago. What's really wild is that this lines up with the middle Miocene climate transition, which, was a time of some pretty big climate shifts on Earth.
Exactly. And to give you a picture of the middle Miocene, imagine, a time with intense volcanic activity, shifting ocean currents, and just global temperatures going like crazy up and down. It's a fascinating coincidence that this period aligns with our solar system's passage through the Radcliffe Wave.
Okay, so maybe not just a coincidence, huh?
Right.
It makes you wonder, like, what kind of cosmic chaos a wave like that could unleash? Was there, like, a supernova party going on?
Well, imagine this, the Radcliffe Wave. It's just packed with stars and gas. As our solar system moves through this, like, really dense region, it's possible that it triggered a surge in supernovae. Those dramatic stellar explosions.
Wow.
Yeah.
Now, that would have been something to see. But wouldn't all these supernovae going off around us, wouldn't that be, like, kind of dangerous?
There's definitely potential for some consequences. Let's just say that.
Yeah.
Imagine a rain of radioactive dust reaching Earth from these supernovae. Not the most hospitable scenario.
Yeah, radioactive dust showers. That's not exactly what I had in mind for a party. What else might this wave have, like, stirred up?
Researchers think that the wave probably compressed our heliosphere. So the heliosphere, think of it as like a protective bubble around our solar system. It's kind of like a shield that the sun's solar wind generates. It protects us from harmful interstellar radiation, so squeezing this bubble could have exposed our solar system to even more interstellar dust and particles.
So it's like opening the windows and letting in, a blast of cosmic dust from the neighborhood.
A very apt analogy. It's also worth noting that some scientists speculate this whole event might be linked to the formation of the local bubble. So that's a region around our solar system. It's known for its active star formation, almost like a stellar nursery.
Oh, wow. Wait, so this wave could have, like, kick-started the birth of new stars.
Possibly, yeah.
That's mind-boggling.
Yeah.
We're talking about events on this, like, truly huge scale that could be impacting our little planet. Makes you feel kind of small.
It really highlights the interconnectedness of everything in the cosmos. What happens out there in the vastness of space can ripple all the way down to our planet.
Yeah, it makes you wonder, are there any clues from this ancient encounter buried somewhere on Earth? Maybe hidden in the geological record?
That's what scientists are trying to figure out. So imagine these deep-sea sediment cores. They're like almost like a cosmic layer cake. Each layer represents a different era in Earth's history. And so scientists are searching for anomalies within these layers, things that don't quite fit the usual pattern.
So they're basically digging through Earth's history, looking for clues.
Right.
What kind of anomalies are we talking about specifically?
One example would be like a spike in the concentration of certain isotopes, like iron-60. Iron-60 is a radioactive isotope that's not naturally produced on Earth. It's created in the fiery hearts of supernova and then scattered across space. So if you find a layer with like unusually high levels of iron-60, it could be a sign that Earth got showered with debris from a nearby supernova millions of years ago.
Like a smoking gun. So have they found any of this iron-60?
There have been some intriguing hints. Researchers found traces of iron-60 in deep-sea sediments, dating back about 2.6 million years. While this doesn't definitively link back to the Radcliffe Wave, it's still, interesting piece of the puzzle.
Yeah. It makes you wonder what other secrets might be hiding in those sediment cores, just like waiting to be unearthed.
This Radcliffe Wave encounter, that wasn't the only time our solar system got like a cosmic makeover, right?
Yeah.
Turns out our solar system's disk, the plane where the planets orbit, it isn't like perfectly flat like we always imagine.
Right. It's, think of it less like a flat frisbee.
Yeah.
And more like a warped vinyl record that's been left out in the sun. The planets orbit in these slightly oblong paths, and the whole disk is slightly tilted. It's A fascinating mystery.
Okay, so our solar system's disk is warped. What could possibly cause something like that? Did we have like a run-in with another celestial object? One prevailing theory is that a massive object, something really colossal, may have passed through our solar system billions of years ago. Its gravitational pull would have been strong enough to warp the whole disk, leaving it with that, kind of twisted shape.
So like a cosmic bully just swinging by and messing up our like perfectly organized solar system.
Yeah,
I'm starting to think our solar system has had a much more dramatic past than we give it credit for.
it definitely has an intriguing history. What's even weirder is that, recent observations suggest that it's mainly the smaller particles in the disk that are warped. The larger objects, like the planets, aren't really affected as much.
That is strange. What could explain that? Are we talking like hidden forces at work here?
One theory is that there's maybe a second ring of material within our solar system. It would be much fainter, much more diffuse than the main one. This hypothetical ring would be made up of dust and other small particles. Yeah. And it could be exerting its own gravitational influence.
A secret ring? That sounds like something straight out of science fiction.
It gets even more interesting. Some scientists even think this second ring, it might point to a massive, undiscovered object lurking out there in the outer reaches of our solar system. Perhaps an ice giant subtly shaping the disk with its gravity.
An undiscovered ice giant. That's a pretty big what if. I'm definitely hooked now. We'll be back right after this to uncover more about this cosmic detective story and what else might be hiding in the depths of our solar system. So before the break, we were talking about a possible undiscovered ice giant, shaking our solar system. It's like we're living in our own cosmic detective novel.
Yeah, it is kind of.
Are scientists, actively searching for this hypothetical planet?
Oh, absolutely. They're using these really sophisticated telescopes and computer models, to look for any telltale signs. It's almost like searching for a tiny wobble in a spinning top. It's subtle, but it can reveal the presence of this unseen force. So in this case, they're analyzing the orbits of objects we already know about in the solar system and looking for any slight deviations that might hint at the gravitational pull of this hidden giant.
So it's a combination of real world observations and theoretical modeling.
Yeah.
That's fascinating. If they do find this planet, it would completely change how we understand our solar system, wouldn't it?
It would be huge. It would be, rewriting textbooks. It would challenge our existing models of planetary formation. And it would open up, entirely new avenues of research. I mean, imagine the possibilities. An entirely new world right here in our own solar system.
It's almost too exciting to think about. Okay, so back to this warp disk mystery. You mentioned that smaller particles are more affected than larger objects. Can you elaborate on what that means for our understanding of this hypothetical second ring?
It's an important clue.
Yeah.
If only the small particles are warped, it suggests that the force causing this warping, it's got to be relatively weak. And this supports the idea of a second ring that's made up primarily of just dust and gas, since that kind of ring wouldn't have the same gravitational pull, as a planet would.
So the second ring, it's more like a subtle whisper than a shout, gravitationally speaking.
I like that.
I'm starting to get this, the interplay of these delicate forces that we're dealing with here, but wouldn't this second ring, even if it's faint, wouldn't it leave some sort of observable trace?
That's the challenge, right? This ring, if it even exists, it'd
Yeah.
be incredibly faint and really hard to see directly. But scientists are looking for indirect evidence. So they're studying the distribution and behavior of comets and other small objects out in the outer solar system, hoping to find patterns that point to this hidden structure.
It's like trying to map a hidden city just by observing the faint trails of travelers passing through the outskirts.
Yeah.
This is mind-boggling. But let's not forget about the other big event we talked about, the Radcliffe Wave and its possible impact on Earth. We were talking about finding iron-60 in deep-sea sediments. But are there any other traces we could look for?
That's a great question. Scientists are also exploring the possibility of finding evidence in ice cores, which they can actually capture atmospheric changes over really long periods of time. So imagine a sudden increase in certain elements or isotopes in a layer of ice that dates back to when our solar system passed through the wave. That could be another clue.
It's incredible to think that these frozen records could hold clues to these ancient cosmic events. It's like having a time machine right here on Earth. But with all this talk about cosmic forces and ancient events, I got to ask, what does this all mean for us here and now? Is this just, fascinating science, or are there, like, real-world implications to all this?
I mean, it's both, really.
Yeah.
While it might seem like these cosmic events are distant and, disconnected from our lives, they've actually played a really big role in shaping our planet. And they continue to influence us in these, like, subtle ways.
So it's not just an abstract scientific concept.
No, not at all.
There's a real connection to our lives.
Oh, for sure.
Yeah.
For example, understanding how the Radcliffe Wave works and the potential for supernovae in our galactic neighborhood, it helps us assess the risk of cosmic events that could impact Earth in the future.
So it's like a cosmic early warning system.
Kinda, yeah.
The more we know about the past, the better we can prepare for the future.
Exactly. The more we learn about the history of our solar system, the forces that have shaped it, the threats that it's faced, the better we'll be able to, face whatever challenges the universe throws at us down the line.
That makes sense. It's like studying history to avoid repeating the mistakes of the past. But on a cosmic scale, I never thought about it that way. It sounds like this research could have practical applications for space exploration too. If we're sending probes and eventually humans beyond our solar system, wouldn't this information be, like, crucial for planning safe and successful missions?
You're right. Absolutely. Knowing more about, where the gas and dust is, the potential for stars to, like, act up,
Yeah.
and the gravitational influences, at play in our galaxy. It's essential if we want to chart safe paths for spacecraft. It's all about understanding the cosmic landscape and navigating it wisely.
This is getting more and more fascinating. It seems like this research has implications for so many fields, from astronomy and astrophysics to, like, planetary science and even space travel. I'm realizing just how interconnected everything is, even on this, like, galactic scale.
It's a powerful reminder that we're not just isolated beings on this small planet.
Yeah.
We're part of this vast and complex system, and everything we do is influenced by forces and events that are way beyond our immediate surroundings.
It's a humbling thought, but also really exciting. It makes you want to learn more, to, like, dig deeper into these mysteries and see what other connections are out there, just waiting to be found. Before we get lost in the cosmos entirely, let's bring it back to that warp disk and the hypothetical ice giant. Are there any other theories out there about what might be causing this working, besides the second ring and the undiscovered planet?
Yeah, there are a couple alternative theories, although they're not as popular. For example, some scientists have proposed that maybe the warping is caused by interactions with the interstellar medium. So that's the gas and dust that fills the space between the stars.
So the idea is that our solar system is sort of like plowing through this interstellar medium,
Yeah, kind of.
and that friction could be causing the disk to warp.
Right.
It's interesting. Is there, like, any evidence to support that idea?
It's still a pretty speculative idea, and the evidence is kind of limited. However, some researchers have pointed to the fact that other star systems, we've observed them with warp disks, so it suggests that it might be a more common thing than we originally thought.
It makes sense that if it's happening elsewhere, it could be happening here, too. It's like we're constantly learning that our solar system isn't as unique as we once believed.
Exactly. The more we explore the universe, the more we realize that a lot of the processes and phenomena we see here, they're also playing out on this, like, grander scale throughout the cosmos.
It's a reminder that we're part of something much, much bigger than ourselves. But let's not lose sight of the mystery we're trying to solve here. We have this warped disk, and we have these, tantalizing clues that point to a hidden ring, maybe a rogue planet, or maybe something else entirely. What are the next steps for researchers? How are they going to try and solve this puzzle?
Well, the search is continuing on multiple fronts. So, new and more powerful telescopes are coming online, which is allowing astronomers to peer deeper into the, outer reaches of our solar system with much greater clarity. And sophisticated computer simulations are also getting better, which helps scientists model the complex gravitational interactions that could be shaping the disk.
So it's a combination of better tools and better models.
Yeah.
Sounds like a recipe for some exciting discoveries in the next few years. But technology isn't the only factor, is it? What about the human element, the ingenuity and creativity of the scientists themselves?
That's absolutely crucial. I mean, it takes brilliant minds to interpret the data, to connect the dots, to come up with new theories, and to design new experiments. The human element is it's at the heart of all scientific progress.
It's like a cosmic puzzle, and we need the best minds out there to put the pieces together. Speaking of brilliant minds, let's go back to the search for evidence of the Radcliffe Wave's impact on Earth. We talked about iron-60 and sediment cores and ice cores, but are there any other like creative approaches that scientists are using to unlock this ancient history?
One really interesting approach involves studying the fossil record. So imagine finding a sudden shift in the types or maybe the number of certain organisms in a layer of rock that dates back millions of years.
Mm.
Could that be a sign of a really dramatic environmental change, maybe one that was triggered by a cosmic event,
Hmm.
like passing through the Radcliffe Waves?
It's like looking for this subtle ripple effect in the tapestry of life. That's incredible. So we're talking about paleontologists and geologists like teaming up with astronomers and astrophysicists to like piece together this grand cosmic puzzle. This is truly interdisciplinary science.
You got it. Solving these big mysteries often requires collaboration across, all these different fields of study. It's about bringing together diverse perspectives and expertise to try and shed light on how these complex forces shaped our world and the universe beyond.
It's a reminder that knowledge isn't, confined to these neat little boxes. It's fluid, it's interconnected, and it's constantly evolving. We need to stay open to new ideas, new connections, new ways of seeing the world.
Precisely. And that's what makes it such an exciting time to be involved in science. We're living in this era of unprecedented discovery.
Yeah.
And with each new finding, we're pushing the boundaries of our understanding further and further.
It's like we're on this grand cosmic adventure, and every new discovery is like a step further into the unknown. But before we get too carried away with visions of this vast universe, let's bring it back down to Earth for a minute. What are some of the practical challenges and limitations that scientists face in trying to study these ancient events? After all, we are talking about, piecing together events that happened millions, even billions of years ago.
You're right. There are definite challenges when you're studying events that happened so long ago. One of the biggest hurdles is just the simple fact that evidence disappears over time. Rocks erode, fossils, they decompose, and cosmic traces that can be obscured or erased by things that happened later on.
So it's like trying to solve a crime scene where, where the evidence has been messed with or partially destroyed.
Yeah.
It makes the detective work that much harder. What other obstacles do scientists face in this cosmic investigation?
Another big challenge is the scale of what we're dealing with. Imagine trying to reconstruct a hurricane by analyzing a few grains of sand that are scattered across a beach. It's really hard to extrapolate from limited data points to get a full picture of these events.
It's like trying to understand the ocean by studying a single drop of water.
Yeah, it's a good way to put it.
It's a reminder of how vast the universe is and how limited our perspective is. But even with these challenges, scientists have made some really incredible progress in understanding our cosmic history. It's amazing what human ingenuity and perseverance can accomplish.
Absolutely. And as our technology and our understanding of the universe gets better, we can expect even more groundbreaking discoveries. It's an exciting time to be witnessing the frontiers of knowledge expanding before our very eyes.
Well, we've covered a lot in this deep dive, from, the Radcliffe Wave's impact on Earth to the mystery of our solar system's warp disk. We've explored some really interesting clues, unanswered questions, and this ongoing quest to, unravel the secrets of our cosmic past. But before we wrap up this journey, I have one last question for you.
I'm all ears.
If we zoom out from these specific events and look at the bigger picture, what are some of the broader implications of this research? What does it tell us about our place in the universe and our connection to the cosmos as a whole?
That's a big question, and one that scientists and philosophers have been thinking about for centuries.
Okay.
Yeah, it really is a huge question, and I think what this research shows us is that we're not separate from the cosmos. We're actually deeply a part of it. The events that shaped our solar system, even, billions of years ago, they still affect us today. We carry the echoes of those events in our very existence.
It's like we're reading our own cosmic history. It's written in the rocks, the ice, even our own DNA. We're literally made of stardust, right?
That's not just a poetic phrase.
No, it's true. And understanding these connections can give us a sense of awe and wonder. A deeper appreciation for the delicate balance that allows life to exist on this planet,
Hmm.
and it emphasizes our responsibility to protect that balance, not just for us, but for everyone who comes after us.
It's a reminder that our actions have like consequences, not just on a local scale or even a global scale,
Yeah.
but on a cosmic scale. If a passing wave of gas and dust, millions of years ago could change life on Earth, imagine the impact of our choices today.
It's a powerful way to think about things. It challenges us to think beyond just like our immediate needs and to consider the long-term effects of what we do. What kind of legacy are we leaving behind? Not just for humanity, but for the planet itself. It's a humbling thought, but also empowering. It reminds us that we have the ability to make a difference, to shape the future, not just for ourselves, but for the planet
Yeah.
and maybe even beyond.
Exactly. And the more we understand about these connections, the ones that tie us to the cosmos, the better we can, navigate our role in all of it.
It sounds like this research isn't just about, learning about the past. It's also about like finding a path forward.
Right. By studying the past, we learn about the present and the future. We learn about the forces that shaped our world,
Hmm.
you know, the challenges we might face, and the opportunities that are out there.
So this deep dive has taken us on like quite a journey. We've explored the crazy history of our solar system, uncovering these clues to ancient events, and asking some really deep questions about where we fit in the universe. What's the one thing you hope our listeners will take away from this conversation?
I think the most important thing to remember is that we're part of something so much bigger than ourselves. Our planet, our solar system, our galaxy. They're all connected in ways we're only just beginning to grasp. And I think that realization should inspire us. It should make us feel, a sense of wonder and responsibility and a desire to keep exploring.
It's a beautiful message, and it leaves me feeling, optimistic and excited about the future of science. What mysteries are we going to uncover next? What connections are we going to make? What new ways of seeing things will we find? The possibilities they're endless.
They really are. The universe is this, vast and mysterious place. It's full of wonders just waiting for us to discover them. And with every new thing we learn, we get closer to understanding our place in this huge cosmic tapestry.
Well said. And on that note, we've reached the end of our deep dive. Thanks for joining us on this incredible journey. Remember, keep looking up, keep asking questions, and never stop exploring. Who knows what amazing things are out there in the cosmos just waiting for us.